Hello, I'll be solving this P3 paper today. This is 9709, variant 32, February March 2022. All non-exact numerical answers have to be given to three significant figures and one decimal place for angles in degrees, unless a different level of accuracy is specified in the question. Also, you need to show necessary working and radians. Answers in radians have to be given to three significant figures as well if they're non-exact. The first one is an inequality. You can do this in two ways. One is a graphical method, the other is just solving them by using inequalities. I'll do the graphical method first. So you need to find out the points, you need to find out the roots of the equation basically. So for this one, for the first one, what is it going to be? When is 2x plus 3, when is 2x plus 3 equals to 0? The one when x is equal to minus 3 by 2, alright? For the other one, when is 3x plus 6 equals to 0? When x is equal to minus 2. Minus 6 by 3 minus 2. You can find out the y-intercept as well. When x is equal to 0, 2x plus 3 is equal to 3. And when x equals to 0 here, 3x plus 6 is equal to 6. These are all the points we need. Okay? So, if we start drawing it, minus 1, minus 2, minus 3, minus 4. So I'm drawing the first one, this one over here. So the x-intercept is at minus 3 by 2. And the y-intercept is at 3. So the graph has a positive gradient, right? This is what we're going to see. Something like this. What about the other one? When x equals to 0, y is equal to 6. Alright, so 1, 2, 3, 4, 5, 6. And when y is equal to 0, x is equal to minus 2. So it's over here. Also, it has a steeper gradient. It's going to be steeper than this. So since it's steeper, just think about it. The difference between the orange line I'm drawing right now and the green line that we already have drawn, that's pointing towards the right hand side, is simply going to increase. It's going to keep on increasing. Can you see? It's increasing. So they'll never meet. So this is the graph. You're going to get something like this. So we have two solutions, right? One of them is like this graph over here, the orange one, and the green one. As you can see, the modulus part, right? The part that wasn't supposed to be there, the part that has been, reflected on the x-axis. This part intersects twice, right? Once with the original part of 3x plus 6 and once with the part that we got due to the modulus. So this is how we're going to solve it. So minus twice x minus 3 is equal to 3x plus 6. This is one of them. And the other one, minus twice x minus 3 is equal to minus twice x minus 6. Okay, so 5x is equal to minus 9, x is equal to minus 9 by 5, and x is equal to minus 3 over here. So these are our critical values. So you can just check using your calculator. 9 by 5 is 1.8. This translates to minus 1. So basically these are the two solutions, right? Minus 3 is the one that's to the left hand side. Okay, so what do we need? We actually want this graph to be greater than the other one. So we want the green graph to be greater than the other one. So when is that actually? When is the green graph above the orange one? In this region, right? Within these 2 points, the green graph is actually above the orange one. So what is our answer going to be? This is the set of points. Minus 3x 9 by 5 minus 9 by 5. Okay. You could also opt for x is greater than minus 3, x is less than minus 9 by 5, but the one on the left hand side is better. What about the other route? There's one more way. How can we do this? Mainly, we can just square both sides to get. This is way number 2. Twice x plus 3 whole square is greater than 3 square x plus 2 whole square. So 4x square plus 12x plus 9 is greater than 9 x square plus 4x plus 4. 4x square plus 12x plus 9. This is what we ended up with. Or minus 5x square minus 24x minus 27 is greater than 0. So if we change signs, we end up with 5x square plus 24x plus 27 is less than 0. This is our end result. So we need to solve this quadratic equation, right? So you need to make a reasonable attempt at doing that. How? You guys know that 5 into 27 is 135, right? So we need 24 if we add it up. How? It's probably gonna be 15 and 9. I'm guessing it's gonna be 15 and 9. So it's 5x squared plus 15x plus 9x plus 27 is less than 0. 5x x plus 3 plus 9 x plus 3 is less than 0. 5x plus 9 and x plus 3 is less than 0. So what are critical values? X is equal to minus 3 and x equals to minus 9 by 5. The ones we got beforehand. So just think about how do we solve these. So this is a minimum graph, right? Since this is positive. So this is a minimum graph with two critical points like this. Minus 3 and minus 9 by 5. So we want our graph to be less than 0. And to be less than 0, it needs to be within this range, right? From minus 3 to minus 9 by 5. But personally, I prefer doing it this way. This is easier to do. Next, on a sketch of an Argand diagram, shade the points, shade the region whose points represent complex numbers Z. So let's go for this. Wait. Here we go. 1, 2, 3, 4, 5. So what is the one on the left hand side? This is basically the circle, right? With radius 2 and center -2 plus 3. Center -2 plus 3. So you need to label these, alright, to get the mark. The examiner wants to see the center with radius 2. So since radius is 2, it's gonna go till this point, then it's gonna go to -4. It's gonna hit -1 over here, and what about this? It's going up to +5 over here, right? So just draw a circle. Wait. Somewhere over here, right? Okay. So just draw the circle, and it has to touch the x-axis, the y-axis, okay? It's gonna be something like this, basically. Something like this, more or less. Wait, just let me draw it. The struggle is real. Right up. This looks fine. Okay, so it has center -2, -2, 3. Okay, and it should go up to, yeah, +5, +1, 0 on the right hand side, and you know, -4 on the left hand side. This is -4. Okay, so what about the other one? So by the way, I drew a bold line because this is less than or equal to. And what about the other one? It's argument of z. So we're going to think of it from the center is actually less than or equal to 3 pi by 4. What does 3 pi by 4 mean? That's actually 135 degrees. So to get 1 by 135 degrees, what do we need to do? It's actually the y is equal to -x line, right? So that's 1, 1, 2, 2, 3, 3, 4, 4, right? So that's how I plotted the points. Then we just draw a straight line joining these points. This is our line y is equal to -x. So this angle over here, right? This is 3 pi by 4. Now think about it. We want the argument of z to be less than 3 pi by 4. So if I shade the region on the right, this angle is less than 3 pi by 4. And this angle over here, this is greater than 3 pi by 4. So it has to be on the right side of this line, okay? What about this? This means that the shaded region must be within the circle since it's less than 2, right? So it has to be within the circle. So what's the correct shaded region? It's going to be this, okay? Hopefully you guys understand. Let's do this next one. What do we have? Ln y is equal to this. Find the value of n and find the value of c correct to 2 decimal places, okay? We know that x to the power n y square is equal to c. So ln x to the power n y square is equal to c, or ln x to the power n plus ln y square is equal to ln c. Sorry, I missed the ln above. Now we can write n ln x is equal to n ln x plus twice ln y is equal to ln c. So what do we need to make the subject? Ln y is on the y-axis, right? That's the dependent variable. So 2 ln y is equal to minus n ln x plus ln c. Now, a common mistake would be thinking that n is the gradient, but it's not. To consider the gradient, you need to make ln y the subject, right? So this has to be ln y is equal to minus n by 2 ln x plus half ln c, right? Now this is fine. So let's find out the gradient, right? Where is the gradient going to be? It's going to be 0.91 minus 1.21 divided by 1.06 minus 0.31. Pretty straightforward. That's minus 0.4, okay? So our gradient is minus 0.4, and we know that the gradient is also minus n by 2. So minus n by 2 is equal to minus 0.4, and n is equal to 0.8, okay? That's our first step. What about the next one? What do we need to find? Find the value of c to 2 decimal places. So to do this, we can just substitute values inside this equation, right? Let's do that. So let's use these points, right? 1.06, 0.91. Okay, so 0.91 is equal to the gradient, which was minus 0.4, ln x, which is 1.06, plus half ln c. So half ln c is equal to 1.334, right? So ln c is equal to 1.334 into 2, which is 2.668, and c is equal to e to the power answer, right? So that's c is equal to 14.411. So just think about it. This should have been to 3 sig fig 14.4, right? But they told us the answer has to be to 2 decimal places. So c is equal to 14.41. Okay, that's it. Let's move on. We have two parametric equations. Show that dy by dx is this. Okay, straightforward. So x is equal to 1 minus cos theta. Dx by d theta is equal to 0 minus sine theta. So that's just plus sine theta. Y is equal to cos theta minus 1 by 4 cos theta. Sorry, cos 2 theta. So dy by dx is equal to minus sine theta minus 1 by 4 into minus 2 sine 2 theta. So after simplifying this, it's minus sine theta plus half sine 2 theta. Okay, hopefully that makes sense. So for parametric equations, there's a marking point for writing this line, the one I'm gonna write. Sorry, this wasn't dy by dx, by the way. This was dy by d theta. Okay, dy by d theta. My bad. So yeah, there is a mark for the next point, which is dy by dx is equal to dy by d theta into the theta by dx. Okay, you need to write this always. Sometimes you need to use this in differential equations too. Okay, you need to show this. Okay, so that's minus sine theta plus half sine twice theta into 1 divided by sine theta. So what's the best way to do this? There are multiple ways. You could divide both by sine theta, but I'm just going to show you a trick. Why don't we do this? Let's apply the double angle formula first. So that's minus sine theta plus half 2 sine theta cos theta into 1 divided by sine theta. Okay. Why did I do this actually? So that I can do this. Now I have minus sine theta plus sine theta cos theta divided by sine theta. Now we can just write this as minus 1 plus cos theta. So now I'm just going to look at the thing we need to prove. This is actually sine square half theta. So I clearly understand that a double angle formula has been used, right? So you guys have the formula booklet. You can use that. You have this. So you know that there's this identity, right? Cos 2 theta. It has three identities. One of them is 1 minus 2 sine square theta. So cos twice theta is equal to 1 minus 2 sine square theta. So what about this? Can't we write this? Cos theta is equal to 1 minus 2 sine square half theta. Doesn't it work? So this equals to minus 1 plus 1 minus 2 sine square half theta. We end up with minus 1 plus 1, that's 0. We end up with just minus 2 sine square half theta. That's it. Okay, shown. Let's move on. Number 5, straightforward sum. Okay, trigonometry. we have tan alpha plus beta is equal to 2, and tan alpha is equal to 3 tan beta. So we should apply tan A plus B here. That's the best course of action. Okay, we can apply tan A plus B. That's in the formula booklet over here. Tan A plus B. So tan A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B, right, is equal to 2. What about this? We know that tan A alpha is equal to 3 tan B, right? So why don't we just substitute that inside here? So 3 tan beta plus tan beta divided by 1 minus 3 tan beta into tan beta is equal to 2, or 3 tan beta plus tan beta is equal to 2 minus 6 tan beta whole square, tan square basically. 2 minus 6 tan square beta. So 4 tan beta is equal to 2 minus 6 tan square beta, or 6 tan square beta plus 4 tan beta minus 2 is equal to 0. 3 tan square beta plus 2 tan beta minus 1 is equal to 0. Let's solve this now. There wasn't a mark for showing this, alright? There wasn't a mark for showing solving. But you could still do this. Like, I'm using my calculator to find out the values. I know that beta is equal to 1 by 3 and minus 1. So I can just do this. Beta plus 1, and 3 beta minus 1 equals to 0, right? So 3 beta minus 1 is equal to 0. So we're getting beta is equal to minus 1. Tan beta is equal to minus 1 basically. So on one end we're getting tan beta is equal to minus 1, and here we're getting 3, or just tan beta is equal to 1 by 3, right? Now what's the rule for tan in general? We get a basic acute angle, right? And then just add 180 degrees to it. And afterwards, like, we get alpha, we add 180 with alpha, and then plus minus 360 depending on the domain. Our domain here is 0 to 180. So if you solve this, remember your calculator has to be in degrees for this question. Tan inverse minus 1 is alpha is equal to minus 45 degrees. What about the other one? If we add 180 degrees to it, that's 135 degrees. Here, tan inverse 1 by 3 is 18.4. Remember, angles to one decimal place, and the other one is 198.4 degrees. Okay, cool. Now let's go for alpha. We know that tan alpha is equal to thrice tan beta, right? So one of them is going to be tan alpha is equal to 3 into minus 1, which is minus 3. The other one is tan alpha is equal to 3 into 1 by 3, which is just 1. Sorry, I wrote beta by mistake, just alpha. Solve this. So alpha, basic acute angle, this is basically BAA, right, is equal to minus 71.6 degrees, and the other one is 108.4 degrees. What about this one? Tan alpha is equal to inverse is equal to 1. So basic acute angle alpha is equal to 45 degrees. The other one is 225 degrees. So let's write our final answers. Which ones fall in the domain? So alpha can be equal to either 45 degrees or 108.4 degrees. Look at how I did not give 45 degrees to one decimal place, because it's an exact answer. I don't need to, right? What about the other one? Beta Let's write BAA here to avoid confusions, okay? Basic acute angle. Okay, so what about the other one? Alpha is going to be 135 and 18.4, okay? 135, I mean. This is it. See if you have any queries, but it's pretty straightforward. For number 6, we have this equation. W square plus 2iw star, the conjugate, is equal to 1. So w is equal to x plus yi, right? W star is equal to x minus yi. So x plus yi whole square plus 2ix minus yi is equal to 1. X square plus 2xyi plus y square I square is equal to, or plus 2ix minus 2yi square is equal to 1. So x square plus 2xyi minus y, so minus y square. You basically need to use I square is equal to minus 1, okay? You have 1 mark for that. I square is equal to minus 1. Plus 2ix plus 2y, okay, is equal to 1. So let's put the real ones together. X square plus x square minus y square plus 2y, that's the real part, and plus I, what do we have? 2xy and 2y, we have these two, is equal to 1. So what's the real part on the right hand side? It's 1, right? So x square minus y square plus 2y, this is the real part, we equate it to 1. And what about the imaginary part on the right hand side? There's nothing, right? So 2xy plus 2y is equal to 0. Sorry, 2xy plus, I made a mistake here. Like when we take I common, what did we have? 2xyi and 2ix. So if we take I away, it's 2xy plus twice x, my bad. Right, so 2xy plus twice x is equal to 0. These are our two equations, okay? Now you need to solve these simultaneously. How? Check this. Xy plus x is equal to 0, right? Or if you take x common, actually, you get y plus 1 is equal to 0. So one of them is x is equal to 0, the other one is y is equal to minus 1. Okay? So if x is equal to 0, when we input x equals to 0 here, what happens? 0 minus y square plus 2y is equal to 1, or y square minus 2y plus 1 is equal to 0. If we solve this, what are we getting? Y is equal to 1. Okay, that's it. That's the only one. And if we input x is equal to 0 over here, what are we getting? Sorry, if we input y is equal to minus 1. When we input y is equal to minus 1, x square minus minus 1 whole square plus 2 into minus 1 is equal to 1, or x square minus 1 minus 2 is equal to 1. X square is equal to 4. X equals to plus minus 2. However, check this out. They told us that x is actually real. They are x and y are real, and the real part of w is actually less than 0. So we are gonna reject plus 2. We need to take minus 2 as the correct one. Okay, so this is actually it. So when x equals to 0, y is equal to 1, and when y is equal to minus 1, x is equal to minus 2. So we need to find out w. Okay, so one of them, w is equal to, this is basically when x equals to 0, 0 plus 1i, or just w is equal to I. This is one of them. What about the other one? When y is equal to minus 1, x equals to minus 2. So w is equal to minus 2 minus 1i, or minus I. That's it. By sketching a suitable pair of graphs, show that the equation this has exactly one root. Okay, let's do this. Okay, so let's draw sec half x first. That's gonna make things easier. Or let's learn sec x first. What's the graph of sec x, which is 1 by cos x? Okay, so this is what the graph looks like typically. There are two asymptotes, okay? So the first one is at pi by 2. The next one is at 3 pi by 2. So this is what the graph looks like. It's gonna start at 1, okay? 1 over here, minus 1 over here. So this is what the first part looks like. At pi, it's gonna touch minus 1. Then it's gonna go like this. So this is what sec x looks like. So what happens when we draw sec half x? We know that when you half the frequency, it's gonna take double the time period, right? So everything's gonna be the same. It's just that everything's gonna take twice the time or twice the angle to complete. Now the asymptotes are gonna shift to double the position of where they were initially. Like pi by 2 is gonna switch to pi, and 3 pi by 2 is gonna switch to 3 pi. So now the new asymptote is gonna be at pi, and the graph is gonna look like this, right? So this is pi, right? This is 2 pi, and suppose this is 3 pi. This is what the graph looks like. Hopefully it makes sense. So what's our point of interest? We want to draw this graph till pi, right? So we can label this as 1, 2, 3, and 4. This is the asymptote. So the graph is going to go up like this. This is, you know, sec half x. By the way, what does pi equal to? What is pi equal to? Pi is 3.142, right? Pi is 3.142. Now think about this, 4 minus x squared, right? 4 minus x squared. When x equals to 0, we know that the graph is going to be equal to 4, y. And when y is equal to 0, x squared is equal to 4, x equals to plus minus 2. So if this is 3.142, where is 2 going to be? Somewhere here, right? So this graph is going to look like this. And we can do something. We can find out the value of this when x is equal to pi. Check it out. So when x equals to pi, what is fx going to be equal to? 4 minus pi square. That's minus 5.86. At pi, it's actually 1, 2, 3, 4, 5, 6. This is actually overkill though. You don't need to go that far. The main marking points are for 1, labeling 1 and 2, and 4 on the axis, and drawing this properly, okay? So this is what the graph is going to look like. Typically, this is it. Something like this. Okay, this is it. It's really hard to draw here. Yeah, this looks good. Okay. So we need to justify this. Like always write this statement after you draw this. You can say that since the graphs intersect at one point, there is Right, so since the graphs intersect at one point only, right, at one point there is only one solution. So verify by calculation that this root lies between 1 and 2. What do we need to do? We basically need to bring them to one side and form an equation. There are multiple ways to do this. Okay. So, for example, we can form a function fx is equal to 4 minus x squared minus sec half x. So we're gonna use f1 first. What is this? Oh, make sure to switch your calculator to radians or else you're not gonna get a correct answer. We're getting plus 1.15. What about f2? Wait, I think I messed up. It's 4 minus 1 minus 1 by cos half into 1. It's 1.86 plus 1.86. What about the other one? 4 minus 4 minus 1 by cos 1. Right? Half into 2 is 1. That's minus 1.85. So what is our argument actually? You could use degrees as well, it's fine. Since the value of fx changes between x equals to 1 and 2, the root lies between these values. Okay, use this iterative formula. X n plus 1 is equal to root over 4 minus sec half xn. Okay, let's start. Write this down in your calculator. Just use 1 by cos, right? 1 by cos half x. So press calc and use x. So you have an option. You can use either 1 or 2 first. Let's just use 1. Let's use x equals to 1 first. One 1.6913, 1.5787, 1.6063, 1.6000. Let's go one more time. 1.6015. We basically have our answer. It's actually equal to x equals to 1.60. That is our root. Okay, so two decimal places. How do we know where to end? When to read the, like, suppose if they want you to find the answer to 2 decimal places, if 2 consecutive roots match till the second decimal place, then you got your answer. For example, this was rounded off to 1.61, this was rounded off to 1.60, so I did not end it there. However, check this out. This is rounded off to 1.60. This is also rounded off to 1.60. That is how we know that we've reached our answer. Okay. For number 8, let's do this. We multiply it with twice x, 8x cubed plus twice x. We just end up with 6, right? So our quotient is 2x plus 1. and the remainder is just 6. Okay, cool. Hence find the exact value of this. So this was a bit complicated. It was a bit more difficult comparatively. So this is basically the one we divided initially, right? So we know that the quotient is 2x plus 1, but 6 is still remaining. So what should we write this as? It's going to be half 0. So twice x plus 1, right? Plus 6 divided by the remainder divided by the divisor, 4x squared plus 1. This is what we should write it as, okay? This is it. Now let's integrate this. How? We can break it down to two parts. Twice x plus 1 dx plus integral half 0 6 divided by 4x squared plus 1. I'm going to teach you two ways to do this. So the first one being, let's do it this way. Half 0 twice x plus 1 dx plus, we can take 6 out, right? Half 0, and we can write this as 1 divided by twice x whole square plus 1. So look at the formula sheet. We know that the integral of 1 by x square plus a square, 1 by x square plus a square is equal to 1 by a tan inverse x by a. One by a, right? 1 by a and tan inverse x by a. Always remember that, tan inverse x by a. This is it. So I'm going to teach you a method. So this is our x square basically. The one inside is our x square. So the integration for this side is pretty simple, right? It's going to be twice x square by 2 plus x half 0, and the one for this side is going to be plus 6. Okay, so think about this. This is our x and this is our a. So what is a? It's just 1, right? So it's 1 by 1 into tan inverse x by a. So here x is actually twice x, right? And a is 1, right? But since there's a twice x inside, we need to integrate that as well. I mean, we need to differentiate that, and it's going to go to the denominator. So we end up with this. Okay, hopefully it makes sense. So it's actually x squared plus x half 0 plus 6 half tan inverse twice x half 0. Let's solve this. So it's 1 by 4 plus half minus 0 minus 0 plus 3. I'm taking the half out. 3 tan inverse half into 2 is 1 minus tan inverse 0. So what are we getting? 3 by 4 tan inverse 1 minus tan inverse 0 is pi by 4. Pi by 4 into 3 is plus 3 pi by 4, right? So 3 by 4 1 plus pi. That is the answer, final answer. So personally, I wouldn't recommend this method because it won't work all the time. I'm going to show you another one. This is a direct continuation from this step. Okay, this was method 1. Now let's go for 2. So half 0 twice x plus 1 dx, and on this side we have 6 integral half 0 1 divided by 4x squared plus 1. So this is the one they use in your course book, okay, this method. So what they do is they actually make the subject, I mean make the first part x squared. Suppose it's 4x squared right here, right here. So we want to take the 4 out. So let's integrate this to make things easier. This is 2x squared by 2 plus x half 0. Right, so let's take the 4 out. So if we take the 4 out, what do we end up with inside? 1 divided by x squared plus 1 by 4, right? What was this answer when we applied the limits? It was 3/4, right? Okay. So 3/4 over here. 6/4 can be written as 3/2. I just reduced it. Half 0. Now we just need to edit this a bit. We can write this as 1 divided by x squared plus half square dx. Okay. Now look, it looks like our formula over here. 1 divided by x squared plus a square, right? So this is actually equal to 1 by a tan inverse x by a. So let's do it. If we integrate this, it's going to turn into 1 by a, which means 1 divided by half tan inverse x divided by half 0. This is it. So we end up with 3/4 plus 3/2. If we reciprocal this, we get 2 tan inverse twice x 0, okay, or 3/4 plus, if we take the 2 out, I mean if we multiply 2 and the 3/2, we end up with 3 tan inverse twice x, right, 0. And we're going to get the same answer. We're going to get 3/4 plus 3/4. So I reckon you should learn this one, the one on the right, because this will work everywhere. And this is what they do in the course book. This won't work all the time, the one I showed you in the beginning, okay? There are two ways to do this, remember. Let's solve this differential equation. How many questions are there? 9, 10, and 11, I'm guessing. Yeah, 3 more. Okay, so the variables x and y satisfy the differential equation this. So we're going to attempt to solve it first. How? We need to separate the variables. 1 by y dy is equal to, we're going to bring them to the right hand side, these to the right hand side. 1 divided by x plus 1 into thrice x plus 1 dx, right? This is it. Now, basically we can't integrate the one on the right. We don't know how to. So what we can do is we can express it in terms of partial fractions, okay? A divided by x plus 1 plus b divided by 3x plus 1. That's the formula. Okay, so if we apply identities properly, what do we end up with? 1 is actually the same as a into thrice x plus 1 plus b into x plus 1. So if we input x is equal to -1, a is actually equal to -half. What about x is equal to -1 by 3? 1 is equal to 0 plus 2 by 3, right? Twice by 3b. b is equal to 3/2. Okay. Now, we have our values. We can write them down here. So integral of 1 by y dy is actually equal to the integral of, so if we substitute a and b properly, what do we end up with? Minus 1 by 2 x plus 1 plus 3/2 3x plus 1. This is what we get dx, okay? Now let's integrate them. Ready? So this is going to turn into ln y is equal to -half ln x plus 1. That's the integration when we have this below. I'm just ignoring the -half, by the way. Plus 3/2 ln thrice x plus 1. And the differentiation inside of 3x plus 1, what's the differentiation? That's 3, right? That's going to go down. That's going to go below 1 by 3. So we can actually get rid of these. Wait up. Plus c, of course. So we can get rid of these 3's. So ln y is equal to -half ln x plus 1 plus half ln thrice x plus 1 plus c. Okay, that's it. Now we need to find out the value of c. We know that when y is equal to 1, x is also equal to 1. So ln 1 is equal to minus half ln 2 plus half ln 4 plus c. So 0 is equal to minus half ln 2 plus half ln 4, or c is actually equal to half ln 2 minus half ln 4. Okay, so c is equal to half ln 2 by 4. C is equal to half ln 1 by 2. So how do we break this down? We can actually write this as c is equal to half ln 1 minus ln 2. Okay, c is equal to half ln 1 minus half ln 2. So half ln is actually 0, right? So we get a value of c is equal to half ln 2 only. This is the value of c. Now I'm going to write the equation again. Okay, so I'm going to write it as ln y is equal to minus half ln x plus 1 plus half ln thrice x plus 1 minus half ln 2. This is it. Now what did they give us a test to do? They want us to find y when the value of x is 3. Okay, so let's simplify our equation first. Ln y is equal to, since there's a half with everything on the right hand side, we can actually do this half ln. So I rearranged it. I just put this on the right hand side and this on the left hand side and that one on the right hand side. Okay, I just switched their places, so I can write it like this. Thrice x plus 1 on the top, and we have x plus 1 and 2 as the denominator. Now what can we do? Ln y is equal to ln 3x plus 1 divided by x plus 1 into 2 to the power half. I just brought the half to the right hand side as the power. Okay, next. Now since both sides have ln, we can actually get rid of ln itself. We can write it as y is equal to 3x plus 1 divided by x plus 1 into 2 root over the whole thing. Okay, now we want to find the value of y when x equals to 3. So y is equal to root over 9 plus 1 10 divided by 3 plus 1 4 into 2. So that's y is equal to root over 10 by 8, or y is equal to root over 5 by 4. That's it. Or you could write this as y is equal to root 5 by 2. That's your answer. Okay, so this was a complicated differential equation, but you should be able to do this in your exam. The vectors was quite simple. Find a vector equation for the line through A and B. So OA is equal to 2 1 1, OB is equal to 1 minus 2 2. Okay, so let's find out AB first. What is AB? OB minus OA, always the one after minus the one before. So AB is actually equal to 1 minus 2 2 minus 2 1 1, which is minus 1 minus 1 minus 3 1. Okay, now let's find out the vector equation of the line. We typically represent it using R. So R is equal to, what's it going to be? The position vector of, like if we draw the diagram like this, A, B, the position vector of A plus a constant. We can't use mu, okay? You can use lambda multiplied by the direction vector AB. So R is equal to 2 1 1 plus lambda 1 lambda minus 1 minus 3 1. This is it. You can keep it this way, or you could also write it in the form ijk. R is equal to 2i plus j plus k plus lambda minus I minus 3j plus k. Okay, this works as well. Find the acute angle between the directions of AB and L, giving you answers in degrees. So let's just use the dot product, right? So what's it gonna be? The direction vector of AB and L. What was that for L? It's actually 1 minus 3 minus 2. is equal to the modulus of AB into the modulus of line L, right? Direction vector, of course, and into cos theta. So the direction vector for our line AB was -1, -3, 1. -1, -3, 1 dot, don't use a cross, 1, -3, -2. That's actually equal to AB. So let's find out the modulus. It's going to be 1 square plus 3 square 9 plus 1, which is root 11 into 1 square plus 9 plus 2 square 4 root 14 cos theta. So -1 plus 9 minus 2, I just multiplied them, is equal to root 11 into root 14 into cos theta. We get 6. So cos theta is actually equal to 6 divided by root 11 into root 14. Just solve this. Angles to 1 dp, right? Theta is equal to 61.1 degrees. That's it. Show that the line through A and B does not intersect L. Okay. So this was the vector equation of our line. And for the line that they've given us, it is actually 1, 2, -3, 1, 2, -3, plus mu 1, -3, -2. So let's simplify these. R is equal to 1 plus mu 2 -3 mu -3 -2 mu, right? What about this one? R is equal to 2 minus lambda 1 -3 lambda 1 plus lambda. Okay, so let's just equate two of them. I'm just choosing the first two. Okay, that's fine, you can choose any one. 2 minus lambda is equal to 1 plus mu. What about the other one? 1 -3 lambda is equal to 2 -3 mu. Okay, so mu is actually equal to 1 minus lambda. This is what we got from here. So 1 -3 lambda is equal to 2 -3 1 minus lambda. 1 -3 lambda equals to 2 -3 plus thrice lambda. Okay, so 6 lambda is equal to 2 -1 plus 3, yeah, 2. So lambda is equal to 1 by 3. What about mu? Mu is equal to 1 minus 1 by 3, which is 2 by 3. Okay, so you're going to get multiple sets of values. Like if you equate the first and third one or the second and third one, you're going to get different values. They're written in the mark scheme. You can find it out. So now what do we need to do to prove that they're skew or do not intersect? We just need to input these values properly. So I'm going to input lambda is equal to 1 by 3 over here. So what do we get? R is equal to 2 minus 1 by 3, 5 by 3, then 1 minus 1, which is 0, and 1 plus 1 by 3, which is 4 by 3. This is the first one. What about the other one? R is equal to 1 plus 2 by 3, 5 by 3. The first two should match, by the way. 2 minus 2 is equal to 0. The last one won't match since we equated the first and second one, okay? Minus 3 minus 2 into 2 by 3. I'm getting a value of minus 13 by 3, right? So since these are not equal, right, they do not intersect. This is what you should show. Okay, you have to show all three coordinates. Remember that. We're doing the last sum now. So we know that in 11, the diagram shows the curve y is equal to sine x cos twice x. Find the x-coordinate of M, basically the maximum point. So for this question over here, we are going to apply the product rule. right? So I'm going to keep sine x normal first. Y is equal to sine x. For cos twice x, the differentiation is minus 2 sine twice x, okay? Plus, we're gonna keep cos twice x normal now, and the differentiation of sine x is just cos x, okay? So y is equal to minus 2 sine x into sine twice x plus cos twice x into cos x, okay? So what is the identity of sine 2x? Sine 2x is equal to 2 sine x cos x. So this is actually, by the way, this was dy by dx, okay? So dy by dx equals to minus 2 sine x, then 2 sine x cos x, right? Plus cos twice x cos x, or minus 4 sine square x cos x plus cos twice x into cos x. Okay. Now I'm going to choose to convert sine square x to in terms of cos square x. We know that sine square x plus cos square x is equal to 1. So this can be written as minus 4 cos x into 1 minus cos square x plus I'm going to convert cos twice x into 2 cos square x minus 1. 2 cos square x minus 1 into cos x. Now we end up with minus 4 cos x plus 4 cos cube x plus 2 cos cube x minus cos x. Now to find out the maximum point, we want to equate dy by dx with 0, right? How? This is going to turn into 6 cos cube x minus 5 cos x is equal to 0. If we take cos x common, 6 cos square x minus 5 is equal to 0. So cos x is equal to 0 and cos square x is equal to 5 by 6. Okay. So it's not going to be cos x is equal to 0, obviously. Because if you do solve that, cos x equals to 0, we're getting pi by 2. Pi by 2 and minus pi by 2. So pi by 2 is our minimum point. That solves it for the minimum point. To get the maximum point, we need to equate this. One of them is going to be cos x is equal to plus root 5 by 6. The other is cos x equals to minus root over 5 by 6. Let's try plus root over 5 by 6. So for the first one, we're getting 0.421 and the other is minus 0.421. What about that other one? Cos inverse minus root over 5 by 6. We're getting 2.72 and minus 2.72. So here's the thing, 2.72, right? Pi by 2 is equal to 1.57. This is 1.57. So clearly, right, it can't be 2.72, which leads us to our final answer. The x coordinate of m is actually 0.421. See if you guys understand. Next, for the last one, we have substitution. Using the substitution, u is equal to cos x. Find the area of the shaded region enclosed by the curve and the x-axis in the first quadrant. For this, we need to find this limit over here. What is this limit? Y is equal to 0, right, for here. So y is equal to sine x cos twice x. So y is equal to 0. Sine x cos twice x is also equal to 0. We can express this in terms of sine. Sine x 1 minus 2 sine square x is equal to 0. Or sine x minus 2 sine cube x equals to 0. Or yeah, just solve this. One of them is sine x is equal to 0. The other one is 2 sine square x is equal to 1. Sine square x is equal to half. Okay. So if we solve this, sine inverse 0 is alpha equals to 0 and pi minus 0, which is pi, which are not the answers, obviously. Sine x equals to half and sine x is equal to root over half and minus root over half. Okay. So we're getting a value of pi by 4 and 3 pi by 4. Typically, it's the first answer, and it's not going to be the negative one, obviously. So our limit is pi by 4. We got it. Okay. So this is probably pi by 4. This is pi by 4. Clearly, it looks like this from the graph. So the limits are 0 and pi by 4. We need to know that. And we want to integrate sine x cos twice x. This is our goal. Sine x cos twice x dx. But we're going to use substitution. How? We know that u is equal to cos x, right? So let's do this. U is equal to cos x. Du by dx is equal to sine x. Minus sine x, basically. So dx is actually equal to, dx equals to minus du by sine x. This was our goal. Now let's also find out the limits. We know that u is equal to cos x. The upper limit is going to be u is equal to cos pi by 4. This is the upper limit. That's root 2 by 2. What about the lower limit? U is equal to cos 0. That's just 1. Okay, so these are our new limits. So let's apply them. Root 2 by 2 and 1 sine x into cos twice x can be written in terms of 2 cos square x minus 1, and in the place of dx I'm going to substitute minus du by sine x. Looks good. I can get rid of these and I can write this as root 2 by 2 1 cos x is u, right? So what can we write this as? 2u square minus 1 du. But there's a minus sign with this, right? So they don't want you to prove anything, but you can just write this as root 2 by 2 1, okay, 1 minus 2 u square du. There was also another way. If you guys think about it this way, root 2 by 2, right? Root 2 by 2 is actually 0.71, which is smaller than 1. If you guys want to fix the limits, this is the other way. You could just write this as 1 root 2 by 2, and you could write this as 2u square minus 1, just removing the sign. Okay, that's another route. That's totally your wish. Okay, it's fine. Let's just use this. I'm keeping the limits the same, but I'm multiplying the minus sign. Now let's integrate this. What are we gonna get? So u minus 2u cube by 3, okay, root 2 by 2 1. So that's root 2 by 2 minus root 2 by 2 cube is root 2 by 4 into 2 by 3 minus 1 plus 2 by 3. So 1 by 2 minus 1 by 6 is root 2 by 3, and minus 1 plus 2 by 3 is also minus 1 by 3. This is going to be your final answer. Okay, so hopefully everything makes sense. If you have any other questions, you can ask me. Okay.